What is Pascal's triangle? Pascal's triangle. What is Pascal's triangle? Pascal's triangle is this really cool thing in math where if you start with one number, right, start with 1, and then you say, okay, I'm going to put a 1 here and a 1 here, right, because 1 is equal to 1 and 1 is equal to 1. And then you kind of continue this idea where you say, okay, well, 1 is equal to 1, this one's equal to 1. Then you want to put a number in the middle, so you do 1 plus 1 and you get 2. And then you do 2 plus 1 and you get 3, and 2 plus 1 here is 3, and then you just have a 1 here, so there's just a 1 there, and there's just a 1 there. You're going to have 1s going all the way down on either side because 1 plus there's nothing else is 1. This 1 plus there's nothing here is 1. So you get 1s going all the way down the sides, but the numbers on the middle, you're going to get different numbers, right? Because they're the sum of the previous two numbers above it. So like 3 plus 1 is 4, 1 plus nothing is 1, so you have a 1 there. 3 plus 3 is 6, 3 plus 1 is 4, and then 1, right? You'll have 1, and then 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 10 plus 1 is 5, and then just 1, right? And you can go further. You can do 1, and then 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, and then 1. And you see that this is kind of symmetrical, right? Like if you go to the left and to the right, you have the same pattern on either side. And you can continue this, right? You can keep going on and on and on. If we go one more layer, you get 1, 1 plus 6 is 7, 6 plus 15 is 21, 15 plus 20 is 35, 20 plus 15 is 35 as well, 15 plus 6 is 21, 6 plus 1 is 7, and then 1. So you can see, again, it repeats on either side, right? Sometimes you have two numbers the same in the middle, sometimes you have 1 by itself, right? And that alternates, right? So you can see, just like that. Now, this pattern goes on, right? You can obviously do this forever. Now, you might be asking, what's the point of this? What's the usefulness of this? Well, one application is binomial expansion. Okay, in the past, if we have something like a plus b squared, we would say, okay, well, let's just rewrite this as a plus b times a plus b, and then FOIL it, right? And you'd have a times a is a squared, a times b is ab, b times a is another ab. You add those together, you get 2ab, and then b times b is b squared. And that's what you would get. Now, look at the coefficients of all three of these terms. You have a 1, a 2, and a 1. Well, if you look back at Pascal's triangle, and you look at this third row here, you get 1, 2, 1. That's not a coincidence. In fact, if you try to do any binomial expansion with any exponent, you can find these coefficients on the triangle. Meaning that if we're trying to do something like a plus b to the third or a plus b to the fourth, instead of having to do this very long, very labored expansion, you can get those coefficients from the triangle. So for example, if I want to do a plus b cubed, how can I do this using the triangle? Well, other than the coefficients, there's other things here, right? There's a's and b's, you know? Well, what do? Well, for the first term, what you have is a to the exponent of 3, right? The biggest exponent you can have here, times b to the exponent of the smallest exponent you can have, which is 0. Okay, and then you add, and then we'll do a, that exponent's going to go down by 1 to 2, the b is going to go up. And then you continue that pattern. Okay, so then you'll have a to the 1, b to the 2, plus a to the 0, b to the 3. And then you stop because, again, 3 is the biggest you can have because this is an exponent 3. Once you have these written out, this is when you use your coefficients. So it's a third degree. So we look at the triangle, and we use this row here, the 1, 3, 3, 1. Okay? So 1, 3, 3, 1. And then you can simplify this, right? Because b to the 0 is just 1. And so this first term is really just a cubed. And then this term here you can write as 3a squared times b plus 3ab squared plus a to those zeros 1. So this is just b cubed like that. And then that's it. So instead of having to do this big, a FOIL and then another expansion or however you want to do it, you can just use the coefficients from the triangle and this technique to figure out what it is. Let's do another one just to get comfortable with this. Let's say we have a plus b to the 4. So same concept, I'm going to set it up the same way. So I'm going to start with a to the 4 times b to the 0 plus a to the 3 times b to the 1 plus a to the 2 times b to the 2 plus a to the 1 times b to the 3 plus a to the 0 b to the 4. So you start with a having the biggest exponent and b having the smallest, and then b exponents go up, right, until they get to 4, and the a exponent goes down until it gets to 0. Then we plug in our coefficients. We go to our triangle. We go to this row here, 1, 4, 6, 4, 1. We're going to plug those in. 1, 4, 6, 4, 1. Simplify, you get a to the 4 plus 4a cubed b plus 6a squared b squared plus 4b cubed plus b to the 4. And you can do this with numbers, right? It doesn't have to be a plus b to the 4. You could have something like x plus 2 to the 5, right? Just as an example. You do it the same way. You'd say, okay, x to the 5, 2 to the 0, plus x to the 4, 2 to the 1, plus x to the 3, 2 to the 2, plus x to the 2, 2 to the 3, plus x to the 1, 2 to the 4, plus x to the 0, 2 to the 5. And then you go and plug in your coefficients. So it's a 5th degree. So we go to the next row here, 1, 5, 10, 10, 5, 1. Plug those in. 1, 5, 10, 10, 5, 1. And now we simplify. 2 to the 0 is 1, 1 is 1. The next term you have 2 to the 1 is 2 times 5 is going to be 10 x to the 4 plus 2 to the 2 is 4, 4 times 10 is 40, so 40x cubed. 2 cubed is 8 times 10 is 80, so 80x squared. 2 to the 4 is 16, 16 times 5 is also 80, so 80x. Plus 2 to the 5 is 32, and x to the 0 is just 1, so that's just 32. Okay, and that's it. So as long as you can remember this system where you write your a and b value, or your x and your number, or whatever you have, write them together where the x, or the first term, has the biggest exponent, the second term has the smallest exponent, and then keep adding them where the exponent on the first one shrinks down to 0, the exponent on the second one grows to 5, write all those out, and then just leave a space to plug in the coefficients from Pascal's triangle. And if you don't have Pascal's triangle with you, well, this is pretty easy to develop, right? You just add the previous terms together, right? This is a 1 because 1 plus, there's nothing else here, is equal to 1. This is a 2 because 1 plus 1 is 2. This is a 3 because 2 plus 1 is 3. This is a 6 because 3 plus 3 is 6, right? So hopefully you're comfortable developing this as far as you need it, right? So if you're asked to find, what is y plus 7 to the exponent 7, you can go down to the appropriate level. You can write out your answer, right, using the structure, and then plug in your coefficients, and you can get an answer a lot quicker than you would be able to if you were forced to expand this manually.